Hello everyone, welcome back to my YouTube channel. I am Yashashwini S. In this video, I am going to discuss about the selection sort. Selection sort is a simple and efficient algorithm that works by repeatedly selecting the smallest or largest element from the unsorted portion of the list and moving it to the sorted portion of the list. This algorithm repeatedly selects the smallest or largest element from the unsorted part of the list and swap it with the first element of the unsorted part. This process is repeated for the remaining unsorted portion until the entire list is sorted. Understanding the brute force approach. Brute force approach selection sort generally when it passes through the list which we number from 0 to n minus 2. The algorithm searches for the smallest item among the lost n minus I elements and swap it with the AI. After n minus 1 pass, the list is sorted. Straightforward and systematic, the brute force approach to selection sort involves a simple step-by-step process of finding the minimum element and swapping with the current position. This direct unoptimized method ensures comprehensive coverage but can be least efficient for large datasets. Comparison-based sorting. Selection sort using brute force technique relies on repeatedly comparing elements to identify the minimum. This comparison-based approach examines the entire data set, making it suitable for wide range of input size, but potentially slower than sophisticated sorting algorithms. Predictable time complexity. The time complexity of the brute force selection sort algorithm is O of n power 2 as it requires two nested loops to find the minimum element and swap it into the current position. This predictable behavior makes it reliable sorting method even if may not be the most efficient choice for large data sets. Step 1. Find the minimum element. Scan the array. Carefully examine the entire array to identify the smallest element. Track the minimum. Keep a variable to store the index of the minimum element found so far. Compare and update. Compare each element with the current minimum and update the minimum index if a smallest element is found. Step 2. Swap the minimum element. Find the smallest element in the unsorted portion of the array. Swap with first, move the minimum element to the beginning of the unsorted section. Repeat repeat the process for remaining unsorted elements. After identifying the minimum element in the unsorted part of the array, the next step in selection sort is to swap it with the first element of the unsorted section. This ensures that the minimum element is replaced in its correct sorted position. The process is then repeated for the remaining unsorted elements until the entire array is sorted. Time complexity of selection sort. Selection sort has a time complexity of O of n power 2, which means the algorithm's running times grow quadratically as the input size increases. This is because the algorithm has two nested loops, one to iterate through the unsorted portion of the array and another to find the minimum element in the unsorted position. Specifically, the outer loop runs n times, where n is the size of the input array. For each iteration of the outer loop, the inner loop also runs n times to find the minimum element. This results in a total time of n star n is equals to n power 2. N power 2 is the time complexity and the array size is denoted by n. 2 is the nested loop, minus is the time complexity. Advantages of selection sort. Simplicity. Selection sort is relatively straightforward to understand and implement, making it a good choice for beginners learning about sorting algorithm. The next one is in-place sorting. The algorithm only requires a constant amount of extra space, making it an efficient in-place sorting technique. Stability. Selection sort is a stable sorting algorithm, meaning it preserves the relative order of equal elements in its input. Implementing selection sort in code. Selection sort can be implemented in the code using simple nested loop structure. The outer loop iterates through the array while inner loop finds the minimum element and it swap it with current element. The algorithm maintains two subarrays, the sorted subarray and the unsorted subarray. On each iteration, the minimum element from the unsorted subarray is selected and swapped with the first element of the unsorted subarray. Comparison with other sorting algorithms. Efficiency. Selection sort has a time complexity of O of n power 2, making it less efficient than algorithms like quicksort and mathsort, which have average case time complexity of O of n log n. Simplicity. Selection sort is a simple algorithm that is easy to implement, making it a good choice for educational purpose or small data sets. In-place sorting. Selection sort is an in-place sorting algorithm, meaning it requires only a constant amount of extra space, making it memory efficient. The conclusion. In this presentation, we have explored the fundamental of selection sort algorithm and its brute force approaches. Thank you for watching my video.